Okay, let's look at a process for teaching equivalent fractions. We want to introduce the term equivalent fractions to the students. They know what fractions are, but not equivalent fractions. And we want to help them to create the abstract procedures necessary to find equivalent fractions, such as multiplying top numerator and denominator by the same number. So we begin with showing some kind of fraction. We have again, the students have the fraction circles at their desks, and you ask them to show you a certain fraction, such as 3/4. And so they show it to you. And then you can talk about this in terms of a pizza, or you can just talk about these the manipulative pieces. And you could say, okay, if I wanted to eat the same amount of pizzas I have here, let's say I'm going to eat 3/4 of a pizza here. I want to eat the exact same amount, not a little bit more, not a little less, but I want to represent the same amount with some of these other pieces here. Can you find that same amount using some of the other pieces? So you let the students explore and try and find the same amount. And a lot of them are going to find things that look like they might be correct, but in fact they won't be. And a lot of them will find, of course, the correct amount using the various pieces here. I want to just start first with, what happens if somebody has an amount that's incorrect. So here I'm going to build this up, and it's going to say, well, it sort of looks like the same amount here. So it looks like whatever these purple pieces are, 1, 2, 3, 4, 5, 6, 7, 7, and these happen to be tenths, so 7/10. Okay. Now I would challenge a student whether they're correct or not, whether they found the correct equivalent fraction or not. I would challenge them to say, well, how can you prove that that's exactly the same? Because to me, it looks a little bit bigger or a little bit smaller. I can say either one, and even if they have the same one, again, if they have the correct manipulative, I could still say, it looks a little bit too big or too small. How could I prove it, or how could you show me that? And the students could lay these on top here. Now, because these pieces are so slippery, they could possibly line them up just like I did over here with gaps and spaces, and they might still look like the same amount. So a better way than just having them do it freely like this is to use the tray and have them put the pieces into the tray, and that way at least you have some way to help align the pieces. So here I'm going to put those in here, so 3/4 in here, and so they believe that 7/10 is the same amount. So as I place these in here, you can see it's a little bit easier for them to line these up and to keep them aligned. So I can see I've got a little gap there, so I move this one up a little bit. Okay. And so they thought 7/10 was going to make it, and I can see here that there's a little amount there. And so 7/10 is not going to work. 8/10 is going to be too big. So I've got the wrong set of fractions, the wrong pieces. Okay, so what will work are these 1/8 size pieces. And so the students find that these dark blues represent 8ths. Will work. They will give them the same amount of pizza or the same area as the yellow 3/4, the 6/8. All right, so what I want to do is I want to collect my data. I'm going to write this on the board. I'm going to say, okay, so we began with 3/4, and you found that 6/8 gives me the same amount of pizza or the same area. Now at this point, I'm going to point out that those fractions look very different. They are different fractions. One's 3/4 and one's 6/8. But in fact, they are the same amount. Okay? So I want to ask the students, how can I represent when two values are the same? How do I write that mathematically? When two amounts are the same, and of course the symbol we use is the equal sign. So here we found 3/4 is equal to 6/8. Even though the fractions look very different, they're actually the same amount. And we find two fractions that look different, but that are in fact the same amount. We call those equal fractions or equivalent fractions. Okay? And so what I'm doing here is I am introducing this concept, equivalent fractions, after the students understand the concept. Okay, so I mean, it wouldn't hurt to begin the lesson and say, today we're going to learn about equivalent fractions. But at the beginning of the lessons, they don't even know what you're talking about. Okay, at this point now, when they understand the concept, it is an appropriate time to introduce the definition, equivalent fractions. Okay, now I'm ready for that. All right, so we have this set of equivalent fractions. I challenge the students, any of the other ones or any other pieces would work to find another set of equivalent fractions or another equivalent fraction of 3/4. And the students are, of course, going to try several of them. And if they try the black pieces, which are the 12ths, that one will work. Okay, so I'm going to write that one on the board. I'm putting this all on the board to collect my data. And it's going to be 9 of those black pieces. Okay, so now I found 2 equivalent fractions to 3/4, 6/8 and 9/12 using these pieces. Okay, I might do the same thing with another fraction, and maybe I would just choose 2/3. So I choose 2/3, as the students represent 2/3, and let's do the same thing. See if you can find something that is going to be the same, not a little bit more, not a little bit less, but exactly the same. And so if they do that, they will find that they will get 4/6, which are these aqua pieces. 4 of those will fit right on there. And they also will find that 8/12. And so we're starting to find a lot of equivalent fractions. Okay? I can also use other types of pieces, like for example, if this were a 1, the base 10 blocks, and it's good to use other things too. It generalizes the learning to more than just these pieces. In other words, we can find equivalent fractions with base 10 blocks and an infinite number of models. So if this was 1, if this represented 1, then each of these rods would represent 1/10. Okay, so I could have used the base 10 blocks and ask the students, okay, to represent 2/10 and find an equivalent fraction to 2/10. And here it might be a little bit easier for them to find this because, you know, there aren't that many really pieces. They know it's got to be these. The only thing I have left are these cubes. Okay, so sure enough, 2/10 is the same as 20 of those hundredths. Okay, so now I've collected a lot of data. I could collect more, but now I'm going to go beyond just introducing equivalent fractions, which is what we've done so far. And now I'm ready with all this data on the board to ask the students, to challenge them to analyze the data and see if they could find a way of finding an equivalent fraction without using the pieces. In other words, and I'm going to direct them maybe at first to look at these 3. Is there some way I could have found 6/8 with just 3/4, or 4/6 with just 2/3, or 21/100 with just 2/10? Okay, and so let them think about it. Depends on the class how their problem-solving abilities. If they aren't, some of them might say, well, if I add 3 to this and 4 to this, I get this. And I'd say, okay, well, let's try that. If I add 3 to this and 4 to this, do I get this? And the answer is, well, no. Okay, so that's not quite working. They might say, if you just add this number to itself and this number to itself, I'm going to get that. Oh, and that does work. Adding 2 to 2 and 3 to 3 and 2 to 2 and 10 to, uh-oh, it's not working here. Okay? Matter of fact, maybe even this one here, I might have left off of this thing here, but we're starting to see some relationships though, and that's the important thing. You might even give them a hint. Like let's say at this point they aren't quite finding anything. You might just say, okay, well, what about multiplication? Could you use multiplication in some way? And let them kind of look at these things. And oh, here, 3 times 2 is 6, 4 times 2 is 8. Okay, 2 times 2 is 4, 2 times 3 is 6. It looks like multiplying by 2 is working here. Okay, oh, but multiplying by 2 here isn't working. Multiplying by 2 here isn't working. Multiplying by 2 top and bottom isn't working here either. Okay, but so far we found something that we might be able to do something with. Okay, so maybe we'll kind of generalize a little bit more and say, okay, well, you multiplied this both by 2 and this both by 2. What would it take here to multiply these by to get to this? And the answer is, well, 10. Okay, so for here we've got times 2. Here we've got times 2. And here we have times 10. Okay, so let's kind of look at this. Would 2 work here? No. Would 10 work here? No. What would work here? Oh, times 3. And here, oh, times 4. Okay, does that help us to find some shortcut to go from here to here? Okay, and the idea is that we keep multiplying numerator and denominator by the same number. Okay, and that's the general rule. All right, so when they come up with that, again, they're the ones creating this. You are just, again, you are facilitating the lesson through questions. You just keep at, what about this? What about this? Okay, so here we are. Okay, so now they come up with this idea that, oh, maybe I can just multiply top and bottom, numerator and denominator, by the same number. Okay, so let's test it. So if I had 1/2, and now for the first time, we're going to try and find an equivalent fraction to a fraction, that we aren't going to use the manipulative pieces first. We're going to try and use this rule that they came up with. So let's multiply top and bottom by the same number. What number would you like? And they might choose 2. Okay, whatever number they choose, that's what I'm going to use. So then the class would be saying that 2/4 should be the same as 1/2. Those should be equivalent fractions. And so we're going to test this by taking 1/2 and taking 2/4, and sure enough, oh, that thing's working. Okay, well, could we multiply top and bottom by another number and just test it up? Test it. Okay, so maybe 1/2. Oh, maybe we'll just choose times 5. Whatever they want to choose. And so the conjecture here is that 5/10 is the same as 1/2. A lot of students will be able to look at that and say, yeah, because they'll be familiar enough with it, but some have to actually look at it. So we have the 1/2 and we have the 5/10, and again, they can line them up. They could put them in here to make sure they're closely aligned. We seem to have found a rule that's working. Okay, and we could try it with a few more problems, not just 1/2 as well. We could try, like 1/5, and we could say, okay, well, 1/5 times 2/2. And so we do times 2, and so on, and we get 2/10, and they could check it. And they might choose numbers that we don't have manipulatives for. Like, for example, they might say, okay, well, let's try 5/6, and let's multiply top and bottom by 3. Okay, so here we might use, rather than a concrete model, maybe we would challenge them to make a drawing of this, because this would be 15/18. Okay, so whether they'd want to make a circle and cut it into 18 pieces, and then look for the 6th in there as well, or if they would like to even use another completely different model. In this case, it'd be nicer to use a rectangle. And so hopefully prior to this lesson, not only have they used these models before in the base 10 blocks, but they've been drawing fractions. And that's a real important thing. That's the developmental approach. Okay, you're always trying to begin with and really getting them to understand a situation, like what a fraction is, in a lot of different ways, with the physical models, the concrete, and more than one type of model, with drawings, semi-concrete, and in this case using circles and rectangles. You could even use a ruler, a linear model, and so on. But anyways, at this point, we've done a couple things. We've introduced the concept of equivalent fraction, and we've helped the students build a way to find equivalent fractions, not just through the models, okay, but through the abstract methods. Okay, so here again we have the same fundamental concepts going through this that we talk about in class. We have beginning in the concrete and moving to an abstract representation, and that's the direction we always want to go. We understand this, the students understand this, they don't quite understand this, but once this starts modeling this, then this starts to make sense. Okay, we place it in a context. When you're using manipulatives, it is a context. if whether I was talking about pizza or not, it's a context. I just added the pizza in there. I could talk about cookies as well. But there's a context. And the reason we do that is because the students understand contextualized things. They don't understand if I just write this on the board with no context. They're just numbers and it doesn't mean a lot to them, okay? But now this represents this. Okay, and that makes sense to them. And then whatever I'm going to do with this, well, I know I can represent it with this over here. You also saw that we began with the concept first, really understanding what we were doing before we labeled it and before we started to try to find some shortcuts, patterns. And of course, that's another thing we saw. We saw that we explored and we found patterns and we tested the patterns. We also used Bloom's highest levels of Bloom's. We used analysis as they analyzed this data. They started to find patterns in there, finding patterns, creation. They're creating patterns. Those patterns are the rules of math. And they're evaluating them. So like if you go way back, if you remember my beginning example, they might have said, well, I can add 3 and I can add 4 and it works here. And then we evaluated that by adding 3 and adding 4 and oh, it didn't work here. Okay, so they evaluate it, then they try again. Okay, so that's the overall strategy for teaching equivalent fractions, both the term and how to get students to come up with the procedures.